Welcome to a lesson with Dr. Powell. Let's take a look at another function here. We can graph and think about it based upon its derivative information. All right, kind of semi-similar to the other example that we saw. That looks something like this. Let's take its derivatives. We get 2 plus, and then we have 5/3 x minus 1 to the 2/3. Okay, take another derivative, and we end up getting, see, 10/9. Oh, x minus 1 is in the denominator. That's going to be a critical problem point as we analyze this one. And that's to the, now that's to the 1/3 right there, power. Okay, so we get our derivatives here. Let's look at the first derivative and see what we can. Now, this doesn't look like there's any domain problems or jumps. So the other thing we can try for is, where is this guy equal to 0? That's a potential place where we could cross over from positive to negative on the y values of the first derivative. Hence, knowing that we change from increasing to decreasing or something like that to see if we get a max or min for the original function. So we're going to look for places where the first derivative might be equal to 0. All right. So in doing that, we set this equal to 0, and it looks like we have something like -2 is equal to 5/3 x minus 1 to the 2/3. Notice this 2, you're squaring something, which means this side's always positive. Well, that can't be. So in other words, it never crosses. It's always going to be the exact same sign. That's a nice thing to realize. So the first derivative is always the same sign because we couldn't find any of those issue points. So what sign is it? We could just plug in anything to see. Or just think this part's always positive if it's not 0, plus a positive. It looks like first derivative is always positive. So the first derivative, we're just increasing the whole time. That means there's no maxes and mins of this function in particular. But maybe there's something to do with the second derivative. Let's take a look at that. So there is an issue point. It's a 1. Now, what are the signs of this guy, of the second derivative, as we go back and forth, the y values of the second derivative? That would tell us concavity information of the original function. So if we take a look at this, we can think, well, this really behaves the same way as the function x minus 1. It's a positive slope. So really it's negative on this side and positive on that side. So concave up over here and concave down over here. But it's always going to be increasing. So you can increase and be concave down. It just looks like this. And you can increase, let's see here, like that. And then you can change to concave up. But you notice it's never going to flatten. It's never going to be 0, we saw. But it does change concavity, though. Graph probably looks something like this at the point. This is at the point 1 here. 1, and then you just stick 1. It's the original function. You get 2. So the point 1, 2, you have this inflection. We don't have any mins or maxes. Thanks for watching.